Since we've been talking about a lot about probability, there is another piece of probability, and that's dealing with expected value. Expected value, by definition, is the sum of the value of each outcome multiplied by the probability of the outcome. Now that's a lot to take in. Realistically, what this looks like is your probability of x1 times x1 plus the probability of x2 times x2 plus, all the way until you're done. Okay, so this is a general formula. Doesn't really make a whole lot of sense right now because you need an actual example with numbers. So here's a situation where we would have an expected value. So our probability distribution, remember, has to add up to a total of 1. So if I look at this, I'm saying that the probability of a 0 is 15%. The probability of a 1 is 30, probability of 2, 25, probability of a 3, 30%. Now, if I look at this, remember, the total of px has to equal 1. And if I do add all those up, it does, so I'm going to go. So what we do with our expected value, we take our x term times that probability. So what I would have is I would have 0 times 0.15 plus 1 times 0.30 plus 2 times 0.25 plus 3 times 0.30. And then I would just go ahead and calculate that. So when I'm doing this, you're just trying to figure out, based on the probability distribution, what should you get based on these different probabilities? Going ahead and calculating all of this, my expected value is 1.7. So pretty easy to get through. The part that gets tricky is when we actually have to use our binomial probability in order to find the expected value. So we've talked about the binomial probability, and you're going to have to use that a little bit to figure out your information. So remember that a binomial probability is where you have success versus failure. So just a refresher, you don't have to write this down because you should already have this in the notes, but I'm just writing it down for good reference. So giving you a situation with binomial probability and the expected value. So with binomial probability, you have that success versus failure. So your success is given as a percentage or as a fraction, depending on what you have. So the expected value is actually a little bit easier to figure out because the probability is always the same. So our expected value for a binomial situation is n times p, where n equals number of trials and p equals the probability. So let's look at a situation. Looking at a weekly forecast. Weekly forecast, I don't need a comma there. Come on, English teacher. Weekly forecast says there is a 30% chance of rain. And not how many days. Find the expected value. Or, you know, what is the expected number of rain days? Okay, so if I'm looking at this, I know that my formula is EX equals N times P. So N in my situation is number of trials. So we're talking about weekly, so it's 7 days. And my probability says 30%. Forgot my zero there, sorry. Starting to get into the percentage. Okay, so this is actually easier than the true expected value sum. So I have 7 times 0.30. So I should expect rain on 2.1 days. Like I said, binomial is actually easier because you already know the probability each time. It's just when you have those different situations of a table that you're going to have to change that up a little bit based on that probability. Otherwise, this is expected value. I think it's pretty simple, straightforward, but use your binomial distribution as well, depending on your different situation.